more talks until beer.
So if you guys come sit down, eat your food, and we have 2 more talks.
Hey Brian, hey Chris George, hey Karen, everyone, sit.
Too excited there. Sorry.
So Rob, you're going to talk about multi-tenant ZFS?
Yeah, I'm going to talk about a bunch of the challenges and things we've done so far and things we'd like to do in the future. And I'll try and keep this brief so people can get back to eating and beer. So basically, there's 2 different problems we have. So we run a multi-tenant environment. Folks are running in different virtual machines. Some are hardware virtualized. Some are just using OS virtualization. We basically have 2 main problems that we want to solve. The first is that we want to have some notion of, you want to have some notion of I/O fairness. This is also true for all the other resources you have, but what's really relevant here is basically disk I/O. And while in straight disk I/O isn't as useful as looking at it at the ZFS and VFS layer, because for most of our customers, what they actually care about isn't what the disk I/O latency is, it's actually what the VFS layer latency is, because if they're doing mostly serving web pages, say, most of that's going to be cached reads coming out of the ARC, so they don't really care about what disk is, and more importantly, they shouldn't care about what the disks are actually doing. And of course, one of the things is that as you buy more, you should be able to get, you're entitled to more of a share of the box. So one of the first things we basically looked at doing is we did this, this was work by Bill Piefsky and Jerry Jelinek with some most recent enhancements from Brian. We're basically adding the notion of a per container I/O throttle. So what that means is that for us, you think of it as basically every customer, so every guest VM runs inside of some OS level container, whether it's ultimately just running a hardware virtualized guest or not. And we want to basically provide some level of I/O fairness. So what that effectively does is it basically cues in off of some of the current ZFS information, basically looks at the percent utilization. We then say, if the disks are actually not very utilized, who cares? Just like, everyone can go use disks because there's no contention. But once we start creeping up towards the 70 or 80% mark, we're going to start kicking in, and basically we're going to use a notion of shares. Basically, different containers have different weights. And basically that dictates how often they can do I/O, and those that have less basically will get throttled for heavier I/O operations. So if you're basically a small tenant who's basically just trying to do a ton of writes, we'll end up having to actually inject up to about 100 mics of basically busy weight on various VFS operations. The idea being that ultimately you want a little guy who's just trying to get a single read in to be able to actually proceed.
So you're actually doing this at the VFS, is all this measurement and everything happening at the VFS layer rather than?
No, this is actually all part of ZFS. Okay. So we basically have running case stats that are collecting, basically, we're using mostly keying off the utilization and basically have running case stats on the containers for both logical operations and the size of those operations.
But you're entering the delays in like ZFS read, ZFS write.
Yeah, it's
not in the I/O.
This is the ZPL layer, not as opposed to that. Yeah.
So wouldn't the ARC cache also make sense, because you cannot allow, when the QoS is to be applied, you also want to apply it on the ARC rather than just.
Well, sure, that's gonna come in. So you're gonna have to come in through the VFS, which will drop you into the entry point of ZFS.
Or are you talking about percent of memory that's
limit
used?
The amount that.
Oh, you're talking about the percent of ARC that's used. Sure, that's something that's not there yet, and we'll talk about things we'd like to go do in the future. But yes, obviously, you're in a multi-tenant system having control over how much percentage of the ARC someone is using.
So you said busy weight. You mean you actually you spit?
You'll spit. 100 mics.
So you'd rather have okay.
Well, because it's a very small amount, but it's just enough to basically allow other people to basically get disk I/O in and get other stuff scheduled. And we'll also kind of play a little bit of games with this scheduling quanta that you have going on. So that's one aspect. The other big aspect that we have is basically you want to have basically controls on ZFS operations. As we all know, if you create 10,000 snapshots on a box, the box is going to be kind of sad. Similarly, if you can create 10,000 file systems, you basically push out the number of file systems and snapshots, things can get pathological. We also don't want, for example, customers to be able to enable dedupe. There's a lot of reasons for that. If you need to ask, well, then you need to learn. And so one of the things that we do with we have delegated data sets that we pass into these zones. So part of the work that it's currently ongoing, it's on review in ZFS, is basically to have the notion of limits for for the number of data sets and snapshots that can happen in the data set hierarchy. So that way you can easily delegate a data set to a customer. Say you're allowed to have 10 snapshots, so you know that even if you have 100 customers on a box, that you're not going to basically run into pretty egregious behavior. You have a question? And then, so those are the kind of the two main things that we're doing today. Those basically allow a lot of functionality for basically untrusted customers to do what they want. Kind of the open things we want to do, one of the big things is basically multi-tenant Arc. It's basically having a notion of having shares in the Arc. So you basically could have, obviously the Arc is going to be growing and shrinking, but you want to basically have some slightly more intelligent choice over basically what data sets are going to be evicted. That's kind of one idea we have that Brendan's kind of toyed around with a little bit. The other stuff we want to do is make receive a little bit more trustworthy. So right now, ZFS send receive is great, especially as long as you can guarantee that ZFS generated the data. So we kind of want to do some receive fuzzing and kind of really solidify that such that you could actually say, take a ZFS snapshot that someone created on their own machine at home and basically be able to receive that elsewhere and not have to worry about a malicious user who's basically crafted a pathological send string.
So in that case, are you concerned with making it not panic the box, or are you concerned with them like not creating a set UID root binary? Right? Those are very different.
No, we're not concerned with the contents of the stream arc as much as the correctness of the stream.
Okay.
So that it won't panic the box, that it won't all of a sudden trick us into saying, oh, we have some 5 petabyte file that doesn't obviously doesn't.
So we've done a few fixes in this area because we have like a test case where it just like injects random corruption into your send stream. And so we've added a few more checks there. I think a lot of that is just around like being much more defensive about the data that you receive.
The biggest one is though that like the objects that you send in the send stream are just data. So you can send a directory, which is a ZAP object, and we don't really have a view into the fact that it's supposed to be a ZAP object. We just write it out, and then we don't find out until someone goes to read the object that it's a ZAP object, but then we assert that
it's the correct ZAP object.
Correct ZAP object.
That's true. That's bigger.
So,
that's a much bigger problem.
Those are the kinds of problems that we want to go and fix. That way, one customer can't obviously come and take out a box. So those are the kinds of problems that we deal with in terms of just multi-tenancy and always working to add more observability up through the stack in terms of being able to see things on a per container basis, in addition to per data set basis things. So that's about it.
All right, great. Max? Other Max? There he is.
Matt talked about it too. I remember.
You remember what he said 10 minutes ago?
Or from this, I think you mentioned this tonight.
So I thought I'd show a little bit of what I've been doing.
You put it on here if you want.
And I didn't really introduce myself before. I'm Max. I work for Joyent, and I do training mostly. When I started Joyent, I was looking at a kernel hang, and I worked on KVM, the KVM port for a year. I started it, did about 4 or 5 months, and then Robert here and Brian Cantrell joined me, and it went much faster after that. And then I went back to what I've been doing for many years. Actually, there's some people in here who've taken classes with me in various places like India and Boston, and where do I know you from?
From your Joyent office.
Oh, okay. So much more recently. So there was the other Max. Is he still here? You're the other Max.
Yeah.
Yeah. So you actually had as one of the topics to talk about education for ZFS developers.
Right.
So I'm going to make a shameless plug. I teach a ZFS internals course. I've done it maybe 10, 12 times now. I'm slowly, after several years of studying it, learning the DMU. Still not there all the way, but and what I do in that is I spend the first day basically doing nothing but looking at ZFS on disk. And I'll use ZDB for that, but I've also been more lately using this MDB that I modified. And I'll explain what I did. I took MDB and I basically, this is back in 2008. So I took MDB and modified it so that I could run it on a raw disk and look at the data structures on the disk. Okay, this is not necessarily the right way to do it. I talked briefly with Robert about this. Robert suggests a new target, and I've kind of flip-flopped back and forth, and now I think new target is the right way to go, but yeah, get on with it. So, let me show you.
So how do you mentioned earlier, like, that it doesn't know how to decompress stuff.
So it's
given
a
that
bit of a
all
pain in the
of
ass.
the metadata is compressed, this seems like
It's a pain in the ass. Not everything is decompressed. There are occasionally ZAP objects which are not compressed. I have no clue why not, but I've got some here.
okay. So I mean, are you saying that you can only look at those ZAP objects?
Oh no, I can look at everything.
Okay. So how does
but
it
what
deal
I
with the
have,
fact
well,
that
no,
they're
what I
compressed?
do is I take the thing I want to look at, and I use DD, or ZDB.
So you use ZDB to read it
Or-
and decompress it.
Well, the thing is, ZDB, if you're having problems with the pool, ZDB minus uppercase R doesn't work well. So what I wrote a little Z uncompress tool that you give it the physical size, logical size, and offset on the disk, and it uncompresses it for you. And you can optionally give it a decompression algorithm in it. And then I'll put that output in another file, and then I'll run MDB on that file. So the file only contains my uncompressed data object, whatever that is. So at any rate, here, just so you can see what I'm talking about here. So here I'm trying to look at a pool called zones, and this pool basically we cannot import. And we do get some nice warning messages, and then it dies with this assertion, even though I'm using uppercase AAA to try to have it not die from this. It didn't matter, it's dying in the assertion, and in fact, all this does, all it gives me, I tried putting it into a file, but then I realized I'm on a RAM disk because this is Smart OS and I don't have any pool available, so it's a RAM disk, so it just fills up the file system and stops after some small amount of data. But then what I did was I tried dumping it out to my screen, and I get basically, it dumps for a long time, and then it dies with this, and it dies with this right after dumping the space map. So it doesn't get me anywhere. I'm not getting there with ZDB. So, bump this one up. So here's basically what I'm doing. I'll run MDB on the raw disk that contains this pool. And I could run it, if I have multiple disks, I can run it on different disks, and, but I'm not going to get into that. I basically pick up the kernel's CTF information. That's what this load CTF is doing. I load a module that has, among other things, this Uber block walker and a couple other things, not all of which work. I had to modify the ZFS module that comes with the system. I had to add 4 characters, ZFS backquote at one place. And now I can look at all the ZFS data structures. And here I'm going to walk the Uber blocks and print each of them out. So what I end up doing with this is I can pipe it, I can look at just the transaction group ID, pipe it to something that does a sort to give me the highest transaction group ID, and here I did that. And here I'm dumping out the Uber block with the highest transaction group ID. And from this, I get a block pointer, and this block pointer is at this location on the disk. This byte offset on the disk. So I'll take that. and dump it out like so. So this looks just like you would see with MDB, and I can see, oh, it's an L0 object set. So from here, I can go and dump out. So what I do is, I tried doing the ZDB here, but this won't work, and with the -C, it doesn't help. Pools exported, it doesn't help. And eventually, I think this time I might have ended up doing DD on it, but I gotta find it here.
The DB is right there.
Yeah, here's the DD. And yes, I seek here and dump out 512 bytes because it told me that the offset fizz-t for the MOS is 512 bytes. So I dump it out. And here I tried, this is still not right because I'm trying to decompress until I looked at my code that I wrote a while ago and realized that basically I could decompress directly. Get there eventually. Okay, so here I gotta back up. That's it right there. So here I'm dumping out parts of the MOS. I'm sorry, the offset fizz-t. So this is the decompressed block that the Uber block points to. So I'm doing this by hand, walking the data structures on the disk. It's time consuming, but I can find everything. I found history, I can look at the space map, I can look at everything on the disk this way. There's some things I want to add. I mentioned I'd like a walker. I have actually written a command that I can just say colon Uber block, and it should give me the current Uber block, which doesn't work. In other words, the command is broken, but this is where I'm going to go with this eventually. Is what I'd really like to do is say colon Uber block pipe colon walk data structures, and it walks everything. But then I realized that basically then I had written ZDB, because that's what ZDB does. The nice thing about this though is that I can find things. So right now what I'm really looking for is, for instance, this here. Where is this? What is it coming from? It's got to be in a ZAP object. Where is that ZAP object? What's going on with this? ZAP object has a object ID, and if I can look at the object ID, I can try to figure out why it's complaining. That's it.
This is great. You should totally finish it.
Yeah, I like I said, I wrote this several years ago, and there was no interest in it and what's happened over time. It's very interesting is over time, now I get an email maybe 2 times a week asking for help recovering files, and back 5 years ago when I didn't have any work, it would have been great to get that email, and now I'm too busy. But yeah, I'd like to finish this.
Yeah.
It's interesting stuff for me. Okay, thanks guys.
Thanks. So I realize that we've lost a few people to the food, but thank you all for coming. The last thing that I wanted to ask people is just kind of for evaluation of this day, and like, I hope that today was useful. Would you like to see like another event just like this in 6 months or a year? Would you like to see something that's like more days, more involved, more customers, you know, like something that's more oriented towards giving presentations to people about the work that you've done on ZFS that we might already know about because it's in the source space, but people using ZFS might not know about. Any thoughts or opinions? I'm gonna ask for a show of hands if nobody has an opinion. Okay, so who wants to do this event again in 1 year? Okay.
6 months.
Okay, 6 months or a year. Who would like to do an event that is like maybe like this, but in addition, maybe instead of the hackathon, have a customer-oriented day where it's presentations for customers. We get a bunch of sysadmins and people like that in here, and other kind of enthusiasts who are not developers. Is that? I know there's a lot of venues for this kind of stuff already, so I don't want to replace.
Customers who would be interested in
Okay.
So,
And would you be interested in speaking at such an event?
possibly in 6 months or a year,
Yeah.
already.
Yeah, but I think that's great feedback. The main thing is I don't want to be replacing other events that are happening. There's already lots of great conferences and all that are kind of specific to each of these communities. FreeBSD has a bunch of conferences. Linux has a bunch of conferences, and Lumos has a couple of conferences. So I don't think that I still want all of us people here to go still talk at those conferences. But if there is interest, then we'll look at seeing what it's going to take to plan a bigger event for next year or in 6 months.
I think the market's there in about 6 months.
Okay.
Yeah, is there any place that these people are already gathered, these customers? And you bring up a good point there. What if there is a conference for development, non-developer users that we could just go to?
Well,
Crash a conference.
yeah, I mean, we could certainly crash a conference or try to. The question is who's and when, because a lot of these conferences are more domain specific. So, for example, we could try to crash BSDCan, which is held every May in Ottawa, Canada. It's 4 days. There's 2 days of developer summit and then and tutorials, and then 2 days of customer oriented conference. So we could ask them hey, can you add one more day that's just ZFS, and we can kind of glom onto your conference. They might be able to do that if we come up with the money and whatnot.
Can we take 2 hours of the customer day? I mean,
Yeah, I mean, we can take 2 hours of the customer day just by proposing talks. That's easy. The issue is more should we create an event of this scale where it's an entire day of ZFS
So there's two. Scale in LA in late February is we could run a full track day of ZFS during their 3 or 4 days that they run quite cheaply. It's getting bigger every year. There's a nice crowd. We got involved because they specifically asked me for Lumos and SmartOS speakers. I'm sure they'd be delighted to work something out for ZFS and possibly use Linux Lisa next year.
All right.
Lisa, that would take a lot more negotiating because they tend to put a lot of money for that, but we might have room there.
All right. So, would people be interested in in speaking at a ZFS track at scale in February?
I can understand.
All right, a few people. All right.
I think we should just put it together and propose it. I
All right.
can talk to my buddies down there at Scale.
Cool.
And by the
Yeah,
way, Brendan is keynoting Scale this year.
We talked to them, they were interested.
They
So,
were.
yeah,
I'm sure.
it's just a matter of if we want to do it.
Yeah.
Cool. So thank you all for coming. The beer will be open soon. Chris has selected the beer. He is our
Basil.
Chris and Basil. I don't see Basil here. The beer is an amazing selection of some of the best beers in the world. So ask Chris more about it.
We didn't go that high.
Okay. Some of the best beers that probably most of you will have ever drank, unless you work for Delphix and go to Chris's private tastings. So great. Enjoy the beer. Enjoy the evening. And tomorrow, 9:30, we'll start the hackathon. So talk about your hackathon ideas. Try to find some people that are interested in your hackathon.
One thing about the beer too, there's 6-packs and things, but there's a couple just big bottles and a couple of small bottles of the same things, and I'll pull out just some small glasses for some of the fancier things, I guess, that we don't have enough for everyone to have their own private bottle. But I'll just put those on right here with some glasses.
Cool. Thanks.